how's it going? Mike coming back at you here with another video on Calculus 1. In the previous video, we talked about the derivatives of inverses of functions. We mentioned the inverse function theorem, and specifically we got into the derivation and the statement of the derivatives of arc sine x, arc cosine x, and arc tan x. We're going to shift on to a new topic. This topic is going to be tied into something that we've spent a good portion of time on earlier on in the course. This topic is going to go back to limits, but now that we're armed with the knowledge of how to find the derivatives of functions, we can now use this guy. So suppose we have a limit of the following form. It's the limit as x goes to a of the quotient of two functions, f of x and g of x. They can be any kinds of functions whatsoever. Polynomials, exponentials, logs, trig functions, whatever. Note that this a value could be negative infinity or positive infinity as well. And this also works if we're doing a one-sided limit. So we could just be taking the limit from the left or just the limit from the right, or we could be working with our two-sided limit here. Now sometimes we find that in that limit, both the functions in the numerator and the denominator, both f and g, both go to 0 at the same time as x goes to a, or sometimes they both go to negative or positive infinity at the same time on their own as x goes to a. So question is, if we have either one of these cases, if both pieces go to 0 or both pieces go to negative or positive infinity at the same time, what do we do? How do we figure out what the limit of this thing is? If we even have our limit, we're not totally sure. Well, this is where our rule and the subject for this video comes into play. If you've seen or heard anything about calculus and limits, then perhaps you've heard of this rule before, but you may not know exactly what it is. And we are talking about, of course, L'Hopital's rule, aka the hospital rule. And L'Hopital's rule says, suppose we have a limit of that form that we saw just now, limit as x goes to a of f of x over g of x, and I call this thing 1. And suppose this limit is such that f and g both go to 0, or f and g both go to negative or positive infinity as x goes to a. Also, we're going to suppose that f of x and g of x are differentiable at x is equal to a. If the limit as x goes to a of f prime of x over g prime of x is a real number, then this limit will be equal to the limit that we were given. 1 is going to equal to 2. The limit of the ratio of the derivatives is equal to the limit of the ratio of the functions that we were given. Now, when we say f and g are differentiable at x is equal to a, obviously if a is negative or positive infinity, obviously it's not a real number. We can't actually plug those things into our function, but we could take the limit as we go to these things, and that's what we mean by differentiable at x is equal to a for those specific values there. Now we're going to see some problems here where you may need to use L'Hopital's rule more than once inside the same problem. You may find that your limit that you're given to start with, both the top and bottom go to 0, or both the top and bottom go to negative or positive infinity, and you differentiate the top, you differentiate the bottom, you take the limit of the quotient of those two things, and then even still those things both go to 0 or that both go to negative or positive infinity. So it is possible that you'll have to use it more than once. We're going to see some sample problems in the next video where that is the case. Now, what is L'Hopital's rule really used for? L'Hopital's rule is used to help us find limits of things that are in a bad form, otherwise known as an indeterminate form. 0 over 0 and infinity divided by infinity are two such forms. In total, there are 7 of these forms, which you see here. 0 over 0, infinity divided by infinity, infinity minus infinity, 0 times infinity, 1 to the power infinity, infinity to the power 0, and 0 raised to the power 0. Now, a couple of these forms you may look at and think, really? That's a bad form? Specifically, 1 to the power infinity and 0 to the 0. We've been taught our whole lives that 1 to any power is 1, and if you take 0 and raise it to any power, you get 0. So you may think, oh, it should just be 1 in the former case and 0 in the latter case. But that's actually not quite true. L'Hopital's rule, just the statement of it, cannot be used when we're looking at limits in these underlined forms here. But what we can do is we can do some algebra or just some working with the function that we're given, and we can transform it to be into one of these two forms here. And then once we have it in that form, we can then use L'Hopital's rule. But as far as what you'll see from me, you will just be seeing limits that are in the first two forms there underlined in squiggly green. Now, the idea behind L'Hopital's rule, what this rule is really doing, is it's saying we can determine the limit of the quotients of two functions by looking at their relative rates of change. Keep in mind that for a function f, f prime tells us about the rate of change of f. So having f over g versus f prime over g prime, having the taking the quotient of the rates of change of f and g, that will tell us is one function growing at a quicker pace than the other, and whichever function is growing at a larger pace, that function will sort of dominate or outperform the other function, and that will sort of help us figure out what our limit is going to be. So this is just an introduction, some background behind L'Hopital's rule, as well as the statement of L'Hopital's rule. In the next video, we are going to go through a few sample problems to see how this rule is actually used. If you have any questions or comments, be sure to drop them in the comment section below. Otherwise, until the next video, take it easy.